And you cut it.
So on the inside of this, we're going to put your definition. So your first definition that we're going to talk about today is a dilation. And a dilation is a transformation that reduces. It doesn't matter. What does it mean to reduce? Small. It's shrinking. Or enlarges a figure. Okay. So think about your pupils. If I take a flashlight and I go straight up to your eyeball and I turn it on, what your pupil do?
It's going to get smaller.
It's going to shrink. Okay? It doesn't want all that light in, so it's going to like shrink up like, oh, that hurts. Okay? If I then push you into a dark closet, your pupils are then going to dilate. They're going to get big. They're going to enlarge. That's what we're doing in this section. Okay? So, if you take this and fold it in half, yes, it's going to make it kind of skinny. And I want you to put the word dilation on the outside. It doesn't matter what side. You want it to be able to open up and see your definition and be able to see the word on the outside. Okay? Make it skinny. Skinny mini. Please don't glue anything in yet because you'll mess it up.
Can you open the button?
Yes, ma'am. We literally shook his notebook out. I don't know where they went.
Did you throw them away?
Somebody's probably over there seriously giggling because they probably have it sitting on their desk. He's missing the little examples.
I'm just trying to say that I just ate that.
All right. Not yet. Okay, we're a little too talkative today. Let's get through this, please. Okay, your second largest rectangle. Find your second largest rectangle. The definition on the inside of this is the ratio. What does it mean to be a ratio?
A fraction.
Fraction.
Yay, look at me being smart. I'm proud. First of all,
Of the lengths of two corresponding sides of two similar polygons.
oh, I thought you were going to say it.
Okay, so everything else we've dealt with between reflection, rotation, translation have been congruent figures. Okay, that means the sides stay the same, the angles stay the same. When you're dealing with dilations, though, my figure's getting bigger or smaller. So they're no longer congruent, but they are similar. Bless you. Okay, so when we're dealing with dilations, the angles are going to stay the same because these figures are similar, but your sides are either going to go up by a scale factor or they're going to shrink down by a scale factor. But again, that's still not going to change the angles. Okay, your angles will always stay the same. What you shaking your head for, Ron? You being awfully quiet today.
He upset about it.
I love you, Teron.
That was sweet biscuit.
Are we good for this?
Yeah.
All right, so when you fold that one in half, the word for this one is scale factor.
All you do is this.
Yeah, we're going next biggest, next biggest. So right now you should have this. Your biggest, your next biggest. Oh no, you just wait. I got you. Okay.
Same thing.
Okay. K is your scale factor. Okay, they're going to call your scale factor K. The first scale factor we have to look at is when we have a number between 0 and 1. So something like 3/4 or 0.5 or 2/3. Okay, notice it does not say negative. Okay, your scale factor should not be negative.
So is it never negative? I didn't mean to say oh my God.
It should not be negative. Because you can't have a negative length. Like the length of a side of a square can't be -4. It's got to be a positive. Okay, so if you have a scale factor that is between 0 and 1 on the outside, you've got a reduction. Yes. So on the outside, you need to put the word reduction.
Wait.
I wish I could laugh as hard as kids.
Bro, breathe. Breathe.
Y'all coughing.
What do we put on the outside of this one?
Reduction.
Reduction. Okay, so if I have a scale factor that's between 0 and 1, it is a reduction. Okay, so your next one should be K is greater than 1. So anytime that your scale factor is greater than 1, that means my figure is getting bigger, which means we have an enlargement. A gigolo.
So is it enlargement?
Okay, yeah, the second one should be an enlargement. Y'all need to get the giggles out.
I'm still thinking
Why
about
we
what I
right when
was
we
watching
vote this
last night.
Huh?
What we right when we ask?
Reduction,
I mean, what we right when we vote this?
enlargement.
I'm chill.
Love and her.
Oh, my master.
No. That was reduction.
Open and large.
Okay, guys, we need to do a little less talking and a little more writing because I keep getting, can we open this back up? Because y'all can't concentrate right now.
Okay.
Get down. Let's get it. Okay.
Can we cut a little bit of this, the longer one off so it's on the page?
Hold on. Hold on. I got you. Enlargement. Okay.
Why my leg keep twitching?
I know this wasn't the longest one.
Ah!
Okay. This is your last one. Okay. To get your points when you have a scale factor, you take whatever that scale factor is and multiply it against both the x and the y. Okay. So you can see it as k on the outside, which means you still need to multiply x and y by that value, or they can have like 4x and 4y, where it's already in the point. Okay. When you fold that one in half, you're going to write rule. That's your rule. And then I'm going to show you how this all glues in.
Miss Smith,
Yes.
on one of the worksheets, you was telling us to find the coordinates after, like, to find the scale factor by giving us the
When we fold it,
coordinates.
it's
Would we
rule.
just divide the dilation by the original? Each point separately?
Technically, the scale factor should be the same for each one, but you should check each one and make sure it comes out to be the same as on the dilation. Because the scale factor can't be 3 for one side and 4 for another. It has to be the same thing.
What is it called?
It's called rule. Roll. All right, friends. No. All right. Here's pages 36 and 37 in your notebook. You are going to take these definitions and glue them across the page like that.
How's that gonna stay in there?
I like that.
Cause it's extra.
Can we use your glue if we're gonna glue it in like this? Use that glue. You got to use
Listen, if you really want to whine about it, put them sideways on one side and put the examples on the other. Sheesh. I try to make it cute and fun. You're like, that's too much. That's too much.
Shut up.
You didn't have to jump in to be complaining. Didn't nobody ask you to put your... No, didn't nobody ask you to put...
Listen.
No, stay there.
You want to talk about other people's AirPods.
What?
I heard you say my name, man. What'd you put that on this album?
No,
On what?
I put it on.
Right, said you act funny now since you got your new earphone.
Just because you don't learn how to do nothing.
I ain't talking about it.
Hey, I was doing
I wouldn't either.
My other glue.
He wanna hear us.
I could care less.
Okay. On the left side of your definitions. On the left side of your definitions, you're putting problems 1 through 4. On the right side, you're putting 5 through 8. I like to angle mine just a little bit.
Yes.
My arm is short. Oh my God, you could be in. Oh, jeez, hush.
Get my daughter.
You said.
No, it's the other way around.
1 through 4 on the left. 5 through 8 on the right. If you glued them in backwards, as long as they're all on this page, it's all right. Everybody gets so sad when they mess up.
Ow, bro. Don't say that. Probably behind me.
What?
She said I'm on drugs. I know you ain't talking. I'm not on drugs.
Oh, I forgot we were recording. I thought you were talking.
All right. So, you're lucky. You're a lucky duck. And I just happen to have 1 extra.
Don't give it to him. Yeah, but they should walk first. I know you did not be you.
Bro, and he's lucky. I had an extra.
You got another one? Y'all saying hers was okay then, bro.
Why can't we be friends? Why can't we be friends?
Oh my God, I'm tired of dropping this plug.
Drop it again.
Hey, I got a Zakiya up here. Hi, friend.
Did you say no? Did you say no?
No, she said hi.
What?
You said no.
Where's my? Oh my God. Did I throw it away?
You threw it away. Thank you.
I'm gonna be honest. With
What, your examples now?
You the best math teacher I done had so far.
I always throw away
What?
whatever I cut out.
Always. I wasn't even talking to you.
Yes, I'm talking about you.
Bless you.
Oh, seriously.
What?
Can you please stop?
I need the hand. If he's not looking at paper. We're not eating like it. No, I didn't.
While you guys are gluing in this last little bit before we do it, it looks like we're going to be testing on Thursday on transformation. Okay. We will have a review day. Okay. But it looks like we're going to test on Thursday, and Friday you guys will have a chance to work on your first project.
Oh, I don't like that.
No, that's all individual projects.
Oh.
Now, when you guys go to do those projects,
Can we not?
those will be group projects.
Oh.
Yeah.
Who wants to do that?
I already don't want to.
What, parallel lines cut by transversal? You build a
No,
city.
but like, I built things.
You build a city?
Yeah.
I wish I could find a program where you guys could do it online.
I know.
I know.
That's
Can I see your glue?
Oh, my
I'm gonna
God.
have to check that out.
You can go to SketchUp and do it.
Yeah.
was that program we used in Miss Walker's class? You know what I'm talking about?
Bro.
Oh, I don't like that.
There's so many things we use in there. But it worked.
Yeah, no.
It does.
What you call it?
You're gonna have to fold it eventually.
The thing we use in the same time? I like that too. I can never work with those, but like, I like that.
All right. We about ready?
No.
No.
No. I get no.
Okay, blue.
Something wrong with me. I think I'm on drugs.
You think or you know?
She is. Oh, I can go make that.
Oh, yeah, we gotta do the example, silly.
I'm just kidding. There's nothing wrong with me, y'all.
Oh, now I
Ain't no lie.
Y'all get over that.
We're leaving at 3. All right, let's book this.
Jump off an elevator.
All right. We're gonna jump back into math class. All right. Identify the dilation and find its scale factor. So first thing you want to do is figure out which one's my old figure, which one's my new. Where's my pre-image and where's my image? My what? Okay. My image is the smaller one right here. This is my image. So that means this one is my pre-image. So if you take a look at that, is that a reduction or an enlargement?
Oh, wait.
Reduction.
Reduction. Remember, it goes from pre-image to image. So this is a reduction.
So we just ignore that over there.
Okay.
Oh my God.
The second thing, bless you, you'll be able to tell me from this is what it's shrinking by. Okay. The way you do that is you take your image and we divide by your pre-image. So pick me a number on your image.
3.
You want to do 3. Okay.
The small one.
We're on number 1. Okay. So you pick the 3 on your image. What side does that correspond to on your bigger figure? 7. So that means that your K value is 3 divided by 7.
That's scale factor?
That's your scale factor. 3 7s. You've shrunk your triangle by 3 7s.
So you're not actually dividing them. You're just setting them up as.
You would divide it if it would actually divide out whole. Okay.
Wait.
I don't know what you did. How you get the 3? You multiplied them.
Because it's on the triangle. You just have to pick a number.
The 7 on the triangle too.
Okay, I probably did that. That's why you put both of them on there.
Okay. I've got people asking questions that I can't answer because you're all being rude and talking over them. If you have a question, please stay quiet so I can answer each one individually. Okay. Go ahead, Sean.
But I'm saying, like, what you do to get the 3 to 7? You get the 3 because, boy.
You could have picked either. If you could have picked the 6. And if you would have picked the 6, it would have went with the 14. And 6 divided by 14 is still going to reduce down to 3 over 7.
Is that just because of the size?
Yeah, that's what it gives you. That side of that triangle is a 3. And the side that it goes with is the 7 on the big one.
So your answer would just be your.
If they ask for your scale factor, your answer would be 3 7s. Okay. What was your question?
So do they ask specifics, like would they say like what's the scale factor of like Q or P, or it's just like all with that one shape?
It's all with that one shape. Because again, the scale factor on each side has to be exactly the same. Okay. Anybody else? All right, take a look at this one. Which one is my image? Which one is my pre-image? Okay, you said the larger triangle is my image, which means my smaller triangle is my pre-image. So what's happening here? Reduction or enlargement? Enlargement. Okay, so again, image divided by pre-image. Be careful with this one because they don't necessarily give you a side of the triangle.
So it's gonna be 15.
What's the distance between here and here?
30.
30. Okay, this entire distance between here and here is 30. So your image is 30. Instead of giving you a side, they give you the distance from the point of dilation out to the figure.
Well, see, that's the whole thing is it'll be 30 and 15.
It'll be 30
How
and
would it be
50.
a whole?
Oh.
It was.
I'm a genius.
It's the free images inside it too. You know what I'm trying to say?
Everything's from the distance of the point. This is your center of dilation. So everything's measured off of that distance. So to get from here to here is a length of 30. So your image is a length of 30. To get from here to here is only 15. So your pre-image is 15.
Oh,
So instead of giving you sides, they gave you the distance from the point of dilation out.
So are you even looking at the shape?
You don't need to on this one. What's 30 divided by 15?
Oh,
Notice my enlargement. Your number was bigger than 1. That's what was supposed to happen. My reduction, my number was between 0 and 1. That's what was supposed to happen. Take a look at number 3. Which one's my image? Which one's my pre-image?
The little one is the image. I mean, pre-image.
The smaller one is my pre-image, which means I have what going on? Enlargement. So when I divide this out, it should come out to be a number that's bigger than 1. Because it's an enlargement. And your definition for an enlargement means that your scale factor has to be greater than 1. So if you get something that's less than that, you did something wrong. Okay. So what number goes on top? 7 and 3 on the bottom. That's an enlargement. Okay, because 7 over 3 comes out to be 2.3333.
There's only 4 things on each side.
Questions on that one?
Me, how is that larger than 1?
oh yeah.
What's 7 divided by 3?
Oh, yeah. It's
Around 3.5.
Oh,
2.3. What's 7 divided by 3?
What is it?
So it's
how's
bigger
it
than 1.
3?
Because 3 plus 3 is 6.
3
It'll be
times.
3 something.
But 3 times 3 times 30. That would be 9.
We're not doing some.
So what?
Okay, hold on. I got you.
Wait, and that's just-
Okay,
that's
so
just-
if I start with 7, how many times can I take away 3?
Twice.
1, 2. So that means it's 2 point something.
Oh, but it's 2.
2.33.
Yes.
If you actually do, let's see how many of us remembered this.
Stop looking at me.
Here we go. Oh, long division.
They taught them a new way how to
Oh
do that.
no. How many times does 3 go into 7? Minus 6 gives me 1.
I feel like I'm in elementary.
Fill in a decimal. Drop down the 0. 3 goes into 10.
3 and 3 and 3.
3.3.
Minus 9.
It's gonna keep going 3.
It's gonna keep doing 3. 2.3.
He stopped looking at me, please.
Why is it that they teach them new ways to do long division?
I don't know.
Because
My kids' teachers are gonna hate me because I'm teaching it the old school way.
I try to help, like I do, and I try to show them, but they're like, I don't know that way. I don't know your way.
Right. All right. Is this a reduction or an enlargement? This is a reduction. This is my image. This is my pre-image. 4 over 10, which actually reduces down to 2 over 5. Shift to the right and find number 5. My favorite student has a headache.
No, I don't.
That's not a joke, Miss Smith.
I thought it was funny.
It wasn't.
Listen.
You heard about feelings.
All right. So this one wants me to find the new coordinates. So the way we start this off is like we start off everything else. Where do I find point A, B, and C right now?
Right there.
Okay.
0, 1, 4.
Thank you, Kathy. 0, 4.
4, 4.
4, 4. And you said 3, 2.
Wait there.
So now, to get my new points, I multiply both x and y by 3/2. Okay, so I'm going to show you the quick and easy way to multiply by a fraction. So, first things first, 0 multiplied by anything is still 0. Okay, to multiply 4 by 3/2, what's 4 times 3?
12.
Divided by 2. 6. Boom.
Wait, sorry, say that again.
Oh
So
my.
you times it by the.
So you times it by the numerator and then divide by the denominator.
Okay.
So 4 times 3 was 12, divided by 2 is 6. So guess what 4, 4 is?
6, 6.
6, 6. 3 times 3 is? Divided by 2?
Like something.
We're just going to leave it as 9/2. Or you could do 4.5. That's the same thing.
So 60.
Okay. And then 2 times 3 is?
6,
Divided by 2?
3.
Okay. So either one of those is correct. Whether they want it in decimal form, which is 4.5, or fraction form, it would stay 9/2. Okay. Number 6.
What bird sounds like that?
Where is A at right now?
I can't even see the line, girl.
Oh my.
-8, -3.
-8, -3. Where is B? -5, -4. Where is C? -2, -3. And where is D? -4, -1. Okay. This time my scale factor is a 3. So is my figure getting bigger or smaller? Bigger. Okay, so we multiply everything by 3. So -24, -9. -15, -12. -6, -9.
Y'all going too fast.
Bro, I gotta do it to look at the board. Right.
But I want to know how to do it.
You done heard like that.
We love you, Tay.
No, you don't.
Wait, how do you?
Be nice.
Wait, so we're doing just multiply the scale
Said don't
factor.
touch his head.
Okay, so again, all I did was take my x coordinates and multiply by 3, take my y coordinates and multiply by 3. Poof, there it is.
Oh, Jesus. It's hot.
Say that.
Yes, I did.
She did.
Okay.
Oh.
Don't talk about me. Yeah, no.
K L M N.
It got glue on it.
KLM.
Okay, be careful with K.
Zakai, give me my.
Actually, be careful with all of them because your scale's going by 2. So each line is now 2. So K is actually at 1, 8.
That's your neck, Bob.
Okay,
Huh?
Oh, I get it. I get it.
your scale is going by 2. So instead of each line on your axis by 1, it's going by 2. So you've got to be careful because if the scale's different, they will tell you that. Okay, so it's 1, 8, 2, 4. 2, 4. -6, 0 for N. Sorry. -6, 0 for N. And -10, 0 for M.
Okay, so you divide by 1. I mean, multiply by 1 and divide by 2.
Multiply by 1 and divide by 2.
Oh, so you already
Let's have come get it.
Oh.
That's what you get.
What it just turned into a negative?
You're just cutting every number in half
Oh, okay.
because you're multiplying by 1/2.
1, 5. Jesus.
So 1/2.
Miss Smith?
Yes, ma'am.
You have Kathy Meza.
I do.
Can you send her to the office, please? She's leaving.
Yes, ma'am. Thank you.
Yeah.
They're gonna try to call police next.
Back to last, please.
Okay. So my first point cut in half goes to 1/2, 4. 2, 4 is 1, 2. -5, 0. And -3, 0.
So you multiply it by,
You're multiplying it by your scale factor here. So everything gets cut in half.
Are you gonna take this out? Yeah, I kept one too. I think that was so worth. You did.
I'm probably just gonna give you guys grades for all that work that you did.
Well, I'm looking
It doesn't matter what order we put our letters in.
No. My mind track as a math teacher is alphabetical order and numerical order. All right, last one. X, Y, Z.
X is at -3, -2.
No, it's not.
Yes, it is. I'm pretty positive it is. I got one too.
-3, -2.
Wait, how? Wait, what happened?
Yes.
Yes.
Wait, what happened? Oh, I didn't see the two.
You was for
Sure you do.
What kind?
Okay.
But it's, you're talking about the X? They're half theirs, but they're not half theirs.
Go Jackie song.
Okay, so -3, 2, 8, 4, and 4, -4. Bye. All right. Okay, my scale factor this time is 3/4. Okay, so -3 times 3, 9, divided by 4. It's 2.25 or -9/4.
Jesus.
This can also be written as 2.25. -2 times 3. -6 divided by 4. -6/4 reduces down to -3/2 or -1.5. Okay, 8 times 3. 24 divided by 4. 6. 4 times 3 divided by 4. So that makes Z really easy then. 3 and -3.